The main purpose of a seal is to separate two environments by being a physical barrier to inhibit the flow of a media from one environment to the other environment. The media could be gas or liquid, and the flow is inhibited because it's unwanted from one side to the other. There are big differences in sealing different media like liquids and gases. For example, a lot of liquids like oils or coolants have very well lubrication behaviors, while gases are very poorly in lubrication, and that makes a tremendous effect on the selection of different materials. What we have here, it is a basic seal setup where we have our seal in the center with the lip in black touching a shaft. In our case, it's a high-speed lip seal where the shaft is spinning very fast, and so the housing is standing still. So it doesn't move, only the shaft moves. On the right side, we have oil, sometimes under pressure or not pressure, or any kind of other fluid. On the other side, we call it the air side. There can be air or can be another media, where we don't want the fluid or the media from the one side go to the left. The lip itself creates the barrier and prevents the oil or the media coming from the right side to the left side by touching with a specific force. We call it the radial force, since it's a round seal, on the rotating surface. We can have three different seal failures. For example, the most easily understandable one is leakage from this side over the seal. If we have not a good casing to housing contact, if we have scratches, damages during assembly, we create a leak path, a channel where the media can flow. It can go inside the seal and find its way on the other side. And then we have the third seal failure, which can be that the media goes underneath the lip. So around the shaft is the most challenging part to seal, because we have an actual spinning part and a dynamic sealing contact. If this contact is interrupted, then we may open leakage path and a channel for leakage. And this would be the leakage underneath the lip. In our test setup, we can detect afterwards by disassembling, but also during the test, where the leakage is coming from. Usually you don't want to see any leakage or moisture after you disassemble it at the outer diameter or in the inner parts of the seal, and that's an indication when you see leakage from the first path or the second path. So it's very important to work closely with the customer to make sure the shaft is in the right condition to our seal. The shaft could be too rough, it could be too soft, it could be too hard, and it could damage the seal, or the seal could actually damage the shaft. This is why we also have the opportunity in our endurance test to test the actual customer shaft in our machine, in our sealing setup, and see if it produces wear or if it's compatible. The leakage we usually prevent by our design. So if we have a runout of the shaft, if we have high speeds, slow speeds, high pressure, low pressure, the physical barrier of the seal has always to be in contact with the shaft. If we lose that, that produces a leak path and results in leakage. It actually doesn't matter what kind of application you want to build a seal for, if it's medical, if it's aerospace, if it's compressors, or if it's automotive. If you have the right designing philosophy by understanding everything from the application and the requirements for the seal, then you can build a seal for everything. Combined with our knowledge and our technology in testing and simulation, this is what sets us apart as an innovative seal designer.